So a little bit of introduction to yourself, because I don't know how much you want to give away, not. Didn't include your LinkedIn this time. So if you can introduce yourself a little bit before we jump in, that'll be very helpful for the
Sure.
audience to get a background. All they know is that you're the tech lead at Partner.
Glad. Of course, the role is synonymous to what the work I do in my actual professional space as well. But hello, everyone. The name's Dinesh, and I've been working in the technology space for almost a decade and a half. And primarily in the past 5 years, I've been focusing on helping enterprises, product companies build solutions using cutting edge technologies. And these cutting edge technologies include primarily how blockchain can fit into their roadmap, what are the use cases that can be addressed using blockchain, and then taking blockchain and integrating with other technologies such as AI, ML, and more interestingly from a software development perspective. So that way, how can a concept, which is just a use case for a business, be translated and implemented into an actual applications where you see the concept panning out within the transactions that are performing on the application. So it's a long story, but I think once you guys get a hang of how to implement solutions leveraging technology, especially around blockchain, then you guys will get a sense about what primarily entails in that role. Okay. So thank you, Kriti, for having me here, and it's a pleasure to work alongside you on the vision that the partner is trying to establish here. And the foundational platform that what we are looking at to solve with Partnr is getting an open access to information. That's a very broad vision, but how this is possible is with the use of this technology that we call as blockchain. And so today's session, we are just going to focus on what exactly is blockchain, what are the core tenets of blockchain. We are not going to get into the details about the specific technology aspects, but more the foundational aspects. That what do enterprises or companies look for when they mean that we are going to go ahead and build the technology on blockchain? Why is anybody even going after blockchain and choosing that as a platform for implementing their solution? So these aspects and a few examples about what we have done as a team on blockchain is what we'll go through it. And then subsequently, if there are any queries, clarifications, we can definitely go through it. And hope you guys get a good understanding from here on. But if there are any queries in future also, you can always reach out to us on our Discord channels. We are most welcome to answer your queries and help you guys get mature into the technology. And that will not just help us, it will basically give us a good platform, good technology on which we can go ahead and build our futures as well. So with that introduction out of the way, let me just get into a quick glimpse about what we are going to do today. I've already covered that we're going to start with what is a blockchain, what are the core concepts, we'll go through some applications, and then what is the current state of blockchain and where we are headed into the future with regards to blockchain. So to start with, what is blockchain? And primarily, I'll not be going through these notes. These notes we'll go ahead and share with you. I'll use the language that is more apt to a very primitive person who's trying to understand blockchain. But we've taken some exact definitions and we'll share these definitions with you. So whatever I'm going to say, it will be in line with what these are, not the exact wordings of it. Okay. So if any queries in between, just please go ahead and put your queries into the chat. And then Kritika will go ahead and pass those queries and we can go ahead and address it at the appropriate interval. So what is blockchain? So blockchain primarily is a piece of software that allows storing and exchange of information in a distributed and decentralized manner. So what are the challenges? Why did this technology even come into existence? So let me take an example with which most of you guys would be familiar with of using Paytm. So everybody would have in some time of this thing would have accessed Paytm or mobile wallets where they would go ahead and store their money, and then this money via the UPI or the QR code scanner, you would go ahead and transfer, use it for your appropriate transactions. So now when you deposit the money, you are essentially providing some financial tokens to an institute, to an entity, in this case Paytm. Now Paytm has your financial assets, and within this assets, whenever you go ahead and do a transaction from your Paytm account to some other Paytm account, essentially the money actually Paytm. All it does is just records a transaction of migration of funds from one person's account to another person's account. So here essentially Paytm is just storing a record of transactions, which is known as ledger, where whatever are the transactions, if anybody wants to go ahead and look at what the current balance is, they would just go ahead and aggregate all the transactions, add all the credits, subtract all the debits, and come with a cumulative value of what is there in your account. So this ledger that Paytm is hosting, today this ledger is only with a centralized entity, that is Paytm. Now, if you take this ledger and move it to a number of other entities, let's say tomorrow the government also decides to intervene and say that, okay, we also want to be a participant to this transaction. We want to just keep an eyes and we want to monitor that there is no fraudulent activity happening. So now whatever ledger information is there towards Paytm, the same information is also present with the government node as well. So now the information is essentially distributed between two entities. And it's not distributed that half information is with Paytm and half information is with government. The entire information is replicated between the two entities. So at a given point in time, if there is any infrastructure attack on Paytm and for some reason it is not able to access the transaction details, it can fall back onto the government's ledger, government's hosted ledger, and then continue performing its operations from the government's ledger perspective. So this is known as distributed, where the same copy of information is actually stored across multiple entities. Now, what is decentralized? Decentralized essentially means that the transaction that you are performing, you are migrating funds from your Paytm account to another Paytm account. So this is a transaction you are performing. But now someone has to go and actually validate that, let's say if Dinesh is transferring funds to Kritika, is there sufficient balance in Dinesh's wallet to even perform this transaction? When Dinesh is transferring funds to Kritika, is Kritika the right recipient? Because all I'm doing is I'm just going and scanning and looking it up. Who knows that behind the scene, the UPI ID or the QR code has been tampered with. So instead of transferring funds to Kritika, I'm transferring funds to someone else. Now, even after performing the transaction, what is the mechanism to make sure that the correct information is recorded onto the network, onto the ledger? So this is where there are certain established mechanisms which Paytm would have designed, saying that whenever a person is transferring funds, step 1, go and check that the person who's transferring, does he have enough balance? Step 1, check performed. Step 2 is that the person who's going to receive should be an authenticated Paytm account holder. Make sure that you are scanning the right ID. Step 2, check passed. Step 3 is that whenever the transaction is happening, just go back and update the balance to make sure that the new balance reflects the debit of the transaction amount. All these 3 steps govern a successful completion of transaction. So now Paytm gives the same set of these 3 instructions to the government also, and says that whenever you receive a transaction that you are going to commit onto your ledger, please make sure you perform these 3 steps on it before committing. So now Paytm independently is performing the same set of actions onto the data, the government ledger is also performing the same set of actions onto the data, and independently they both are coming to the same result. This is known as decentralization, where the entities that are participating into the transaction, they don't rely on the other entity to tell them the results of the transaction, results of the action that is performed in between the transaction. This is where the decentralization aspect happens. If it was a centralized aspect, Paytm would perform the transaction, and the result of what the final state of data looks like, Paytm would go ahead and replicate onto the government's ledger, which is what probably during your experience you guys would have heard about client server architectures or master slave architecture, where the entire operation is primarily done only on a single node, on a single entity, the master entity or the server entity. Whereas blockchain is slightly different, wherein in the case of decentralization, every entity that is participant to the network is responsible for performing the actions and independently confirming the results of those actions. Now, these actions can be defined by an individual, or they can be defined by the group of the participants into the network together. But once these actions are defined, every participant is expected to adhere to these actions. So just throwing this concept out here also, that you would have heard that there is something known as smart contracts into the blockchain. Smart contracts are nothing but the actions to which a transaction should adhere to is codified into its appropriate algorithms or programs. It is known as smart contract. So theoretically, smart contracts are not smart. They are programmed. They are programmed to perform the same set of operations over and over again. So they are deterministic programs that no matter how many times you feed the same set of input, it will always give you the same set of output. Okay. So now what we do is, with this piece of information, there is an actual application that I just wanted to go ahead and show you. So we discussed the concept. Now through the session, we will mostly be doing a bit of hands-on, so that way you guys get comfortable about what the foundational concept means, and that way your knowledge about these concepts will be improved. Okay, and these links are also being shared along with the reading material, so at a later point in time you guys can go ahead and just try performing the same operations, or in case if you guys want to go ahead and do it right now, just within Google itself, go and search for this guy Anders Brownworth / blockchain, and you will get these appropriate demo URLs. So basically there is this guy Anders Brownworth who did a fantastic job, that he created an application to mimic these core concepts of blockchain. When the technology was conceptualized, it became very challenging for people to understand what is cryptography, what is the essence of programming in it, what are tokens, hashes. So all he did is he created a very basic application to represent these concepts, where anybody who wants to understand can come and start playing with his application and test out each of this concept right from its basic in an individual isolated form, all the way to how this concept pans out into the blockchain. Okay, so the very first concept is that blockchain is formed on the principles of cryptography. Now within cryptography, so what it means is that if you go ahead and have a conversation between two participants, so let's say two friends are going and are talking about a certain specific aspect, the information by itself has no value, because most of the times people talk in pronouns, people talk in references, where to a bystander he will be completely clueless about what the actual information is or what the context of the details around the topic is. So what it means is that information within the context adds value. Information without the context has no value. But given the context that the two friends already are familiar with the background that is being discussed, when the conversation happens to a bystander, this will be a completely cryptic conversation. But then the communication effectively happens between the people because they have some past references to it. In a very simplistic term, this is what encryption means. Encryption essentially means is that you put your data into a wrapper and then go ahead and send this wrapper over the network to everyone, and only the intended participants have an understanding about what this information is, and for rest of the guys it is just a gibberish message out there. Now it is very difficult, it's not possible to decrypt the information. So that way only if someone has those appropriate context, which in some time we'll get on to what that context is. But just remember this aspect, that only someone who has the context can be able to extract the information, not decrypt. There's a difference between decrypting and extracting. You cannot decrypt a message once it is encrypted. You can only extract the meaningful information out if you have the right means and the right keys to go ahead and perform the operation. Okay. So one of the very basic mechanism is hashing algorithms. So now there are several hashing algorithms, and the most prominent is SHA-256. There are others such as KeyChack-256 and few others. These are mostly used in all communications and approved by NSAs and all the government agencies, that whenever they are performing some secret this thing, they use these methodologies to go ahead and perform the transactions onto the data. Now, this is a piece where whatever data you enter, you can even leave a space, you can even type ABC. The hash that you see at the bottom, this is the digital fingerprint of the text that is entered into this data input area. So if you leave this as blank, you see that something is starting with E3B and ending with 855. Now, the moment you even put a space here, or you put a dot, or any alphabet character that you put, you can even put an entire your Congress book also into this, and still it will give you one hash that is uniquely representing that Congress book. So similarly, and every time you give it the same input, it will give you the same output. So again, we go back, we see that it was the same E3B at the beginning and 855 at the end. So this is hash. This generates a digital fingerprint of whatever text or input that is passed into this data box. Okay. Then the second tab here, just give it a second, it's loading. The second tab here is blocks. So theoretically, you guys are now smart enough to understand that blockchain is essentially linking a chain of blocks. Now, what are these blocks? These blocks are nothing but pieces of information grouped together in a time boxed window. So today I go ahead and I say that at 12 o'clock, I start my time boxing event, and that at 12:05 I stop. So whatever are transactions between 12 and 12:05 is what I'm referring to as one block of transactions, grouping of transaction within that time boxed window. Okay, so that is a block, and there is a link that whenever the next block is built, there is some reference to the previous block. That way it's a chain, it's a sequence of one block to the next block. Okay. So take an example that there is some block 1 here, and I'll come to this nonce, and now there is the same aspect of data where we can go ahead. So whatever data you type here, again with a combination of block number, whatever is the number that is entered here, there is this random field which is some numeric number that needs to come here, and the data here. So together with a combination of these fields, the hash is generated. Okay. Now, most of you guys would be familiar with Bitcoin. That in Bitcoin, there is a mathematical problem that needs to be solved. So what is this mathematical problem? The mathematical problem is that change this value of nonce to any number such that the first four digits of the hash are all zeros. This is the mathematical problem. So what it does is it starts with 1. The program goes and every time it starts with some basic number and then keeps on incremental checks with 1, checks with 2, checks with 3. So it has to just go ahead and perform a series of repeated calculations that can go ahead and give a nonce value which will give you 4 zeros. So here Mr. Anders has taken care of this, and when we click on this mine button, it automatically is performing the operations behind, and it is giving us this nonce value with which we are getting the first 4 zeros. Again, you want to go ahead and make changes, add some more text. Again, it changes, click on mine again. Again, it goes and generates a new nonce value that will help you get the first 4 digits as zeros. This is the actual problem that is being solved in bitcoins, with which the each of the miner node competes, and whosoever is able to solve this problem first, that person, that entity gets rewards for solving the problem. Now, solving the problem is difficult, but verifying is very easy, because all we do is within the application we just pass this block number, we pass this nonce and this data, and if it gives, yes, we match with the results. If it doesn't give, that block is discarded and everybody again starts performing the repeated set of operations. So the entire computation goes only within the generation of blocks, which is nothing but sequentially, incrementally iterating through the problem to generate a number that can yield 4 zeros here. Okay, so this is the aspect of block. Now let us come into blockchain. So we've understood what hashing is, we've seen what a block looks like. Now let's go ahead and create a chain, start linking the blocks with one another. And how this linking happens is based on the hash. So every block has these 3 fields which we already saw before, which is the block number, the nonce, and the actual data. And to this we also add the previous hash number. Now when all of these are combined, you go ahead and generate a hash with which you make sure that the problem or the governance that is accepted, in this case, in the case of Bitcoin, it is first 4 0, you generate some nonce which is giving you first 4 0. And this way it makes sure that there is a sequential linking between one block to its successor. And the very first block is usually known as the genesis block because there is no reference. So that's where it comes with all zeros here as a previous reference. But all the successive reference, you will see that this is the previous reference. So the current hash is passed on as a previous value to the next hash, 00012, 00012. So subsequently, this is the linking that happens between one block to its next block. So now, how it becomes a tamper proof. So we saw that whenever any data is added here, it changes the hash value. So now with this, what has happened is we've lost that initial zeros, the number which at a combination of which, so if I again remove, this is the nonce number that for no value is actually going and generating these 4 zeros. The moment I change, I add any value here, the entire this combination changes and now it will give you a different hash. So our agreement was that the hash is valid only if it is starting with 4 zeros. So now again we go ahead and click on mine this block. So we are mining this block, we get a new hash which is this, but now the next block is referencing to this hash. Now the hash of this block has changed. The nonce that was there was actually giving 4 zeros with the previous hash. And now because some data has changed in this has given us a different hash which is not starting with 4 zeros. So now subsequently you need to go ahead and mine every block. Mining is nothing, you're solving the problem and getting the zeros here. So every block subsequently that is there, you have to go, you have to solve the problem, and you have to generate a new value that provides you the same with the 4 zero hash. And the same step with all the blocks that are there, the entity has to make sure that they go ahead and perform this operation on each and every block that is part of the network. This is an extremely computational intensive operation, even to mine one block, because right now we are just looking at it as an individual entity, but within an actual ecosystem there are other participants also with whom you are competing, with whom you are collaborating in making sure that the data gets committed to the network, to the blockchain. Okay, so now we have seen blockchain. Let us come and look at the distributed aspect. That how is it essentially coming as distributed and decentralized? So imagine a network. Okay, network is nothing but a group of participants that are participating in a transaction. Okay, and the case of example that I gave you was the Paytm and the government. So they are two participants. Ideally, every participant of a transaction should host their own nodes. So in a realistic world, let's say you are the entity, you are performing a transaction. So you would want your data, your transactions to be secure. So you should go ahead and spin off a node. And then whatever transactions you are performing, you should go ahead and do it on your node, not on anybody else's node. But then in a realistic world, it becomes practically impossible to have these type of operations, that not everybody can host a node. So that is where there are designated participants who are chosen, that they will act as aggregators, and all individual members or other participants who are going to be, who have agreed to choose an aggregator, go ahead and perform their transactions via the aggregator. Okay, so imagine this network where there is a peer A who is hosting the infrastructure to perform the transaction. There is another entity, peer B, who is also hosting the infrastructure, and then there is peer C. So we have a 3-member network here. Now, one important aspect is, how does the data come to the network? So we said that there are individual participants who have to perform the same set of operation and come with a result. So now when the results are there, how do you decide which results have to go through? Let's say that there are only 2 participants into the network, me and Kritika. I come with result 1, Kritika comes with result 2. How do we come to a conclusion on whose results to go ahead and capture onto the network? So this is known as the consensus mechanism, and consensus essentially means is go with the majority. So in a 2-member, there is no majority. There always is a minimum. For majority to come, there needs to be always odd participants, which is 2n plus 1 should be the minimum number of nodes that are participating in the transaction. And that way, with the 2-member, it will not work out. There can be a stalemate. The entire network can go down that no transaction is getting committed because both the members are giving conflicting results. So that's where we add one more entity. And now between the 3 entities, whenever 2 entities, which is the majority, it needs to be more than 51%. So whenever the majority agree onto a result, that block gets committed onto the chain, and all other blocks get discarded. Okay, so this is known as consensus mechanism. So now in this example also, there are 3 individual participants. One is peer A, another is peer B, and the third one is peer C. And they all have the same copy of transaction, and they are performing the same set of operations. Now, peer A wants to go ahead and change the data onto the network. He wants to go ahead that instead of this blank text box, he wants to go ahead and put some text here. So he goes and puts this text. Because this is the most recent block, he goes and mines this block also onto his node. Right now, basically the computation is happening on peer A's node. So on his node, he does the computation and he generates the nonce value and he generates the hash value along with the data set that he has. But the problem here is that the other nodes who are participating into the network, they go ahead and they both perform the operations independently on a different data. And when they both generate the nonce, so they see that the nonce value is 5625 and they see a different hash. Similarly, PSC also comes. PSC says that this is the nonce and this is the hash. Now, peer B and peer C's hash matches, but peer A's hash is out of sync. So they discard peer A's block and they put peer B and peer C's block onto the. He will always perform computations that are wasted, and after a period of certain erroneous blocks, he will get flagged out from the network. So no longer will he be able to participate in the transactions. Okay, so this is how the concept of consensus pans out and ensures that if there are erroneous members who are participating in the transaction and continuously they are performing transaction, they should be flagged out from the network itself. So that way there is sanctity of the network maintained. Okay. Now the same context is also applicable onto the tokens. What we saw here is just blank text boxes, but within an actual blockchain, there will always be some transactions that are happening. Actual transactions, in this case, it's Bitcoin based. They are showing the transaction from person A to person B. All of these transactions are there, but the underlying concept still stays the same. That, for example, if peer A goes, that this transaction from Dennis to Edmund, he tampers with this, and instead of giving 114.12, he gives it 140.12. And then he goes and clicks on mine. He gets a different nonce, different hash, which doesn't align with the hashes and nonce of other members. Okay, so context is the same. This is how a proof of work operates onto the network, wherein every participant has to show some proof of work that they have performed to commit this block onto the network. So you guys would have heard that Bitcoin is on proof of work consensus. It is partially true. The consensus is not just proof of work, it is proof of work plus the longest chain. If you are doing on a different chain, then your records will never be committed onto the actual network. You need to make sure that whichever is the longest chain, that chain is accepted as de facto by the entire network. And this consensus is actually known as Nakamoto consensus. So proof of work plus the longest chain. Similarly, there is an alternative consensus mechanism, which is proof of stake. So proof of work is very computationally intensive, and as more number of participants come onto the network. So today here as an example, we are only seeing 3. So between 3, 2 guys have to agree to a common state. But imagine a state where there are 100 participants, because this is open. Anybody can go ahead, put up his node, and then start performing the operations. So if there are 100 participants, the transaction has to wait for 51, minimum 51 participants to agree onto a value before committing it onto the chain. So it becomes very computational intensive and competitive also out there with the nodes. And that's where you see that instead of any individual player going and putting up his infrastructure, there are certain mining pools where instead of going solo, you go as a group, you compute your infrastructure to a mining pool, and then together with the mining pool, you are going and performing the computation. So technically, more the number of nodes, more secure is the blockchain, but with that security, there is a compromise of throughput and scalability into the network. There was a time when to commit one block onto the network, it would take about more than 48 hours. Essentially, every block gets committed at every 5-second interval. So depending on the problem, you can go ahead and determine the time of block. If you keep the problem very simple, instead of 4 zeros, you say that I just want 1 0, then it's a very simple problem and the blocks get created at a faster pace. If you want a complicated problem, you can say that instead of first 4, I want the first 10 as zeros. Then the complication, the problem is a bit more complicated and the blocks will get created at longer intervals. So the network determines the size of the blocks and the time the blocks gets created. But at the same time, more number of participants brings in trust, brings in assurance that there will be no tampering. But at the same time, the scalability and throughput is impacted, and that proportionately increases the cost of transaction. So to circumvent this, there is another mechanism, consensus mechanism that is coming out, which is proof of stake, where on a random basis, there will be a set of participants that will be chosen, that instead of solving a problem, you will go ahead and put your stake. So you will own some rewards and this thing, which you'll go ahead and put it as a stake. And then the other members will just go ahead, validate the transaction. And if your transaction is successfully accepted, then you get rewards for your stake. If not, you lose your complete stake. So in June, Ethereum is going to come. There is a beacon deployment where Ethereum is going to be migrated. The mainnet is going to be migrated to proof of consensus, proof of stake consensus mechanism. This has been in the works for past 3 to 4 years. But again, the infrastructure that in Ethereum has become, it takes a lot of pain, effort, and in an open network, consensus from the participants to make sure that they are able to move the network or pivot it to a different mechanism. Okay, so this covers this. Now, from the same this thing, there are certain cryptographic aspects also that I wanted to touch upon, because along with the decentralization, the distributed, cryptography is an equal aspect that plays within the security of blockchain, and we'll just spend 5-10 minutes to understand how this works out. So using elliptic curve cryptography, for every on an elliptic curve, basically, again, let's not get into the details, but just have this concept that just like today, to manage your accounts, you have your user ID and password. From a cryptographic perspective, the same gets translated into a public key and a private key. So private key is equivalent to your password, public key is equivalent to your username, and private key is what you keep with yourself. Don't disclose your private key to anyone, because the moment you have anybody has access to your private key, on your behalf they can go ahead and perform the transaction. And these are non-repudiable, means that anybody who has the private key can provide the identity, whereas public key is available across. You can go ahead and publicly boast about what your public key is, because using the public key, anybody wants to do transaction with you, they should know about your public key, otherwise nobody can go ahead and perform a transaction with you. Now this is again, this is the same application from Mr. Anders Brown. So here he's created a small web app using which he's demonstrating how public key is generated from a private key. So you can always generate a public key from a private key, but you cannot reverse engineer a private key from a public key. It is non-reversible operation. So here you can go ahead and provide any, you can choose, I'll choose one as my private key. It will give you this as the public key. Similarly, you can go ahead and choose any other distinct key. It will provide you a public key associated with it. Click on random, it generates some random private key associated with which there is a public key. So there is always one-to-one mapping. There will never be a case that you will have two private keys that are mapping to one public key, or two public keys mapping to the same private key. No, it's always one-to-one mapping. You can generate public key from the private keys, but you cannot reverse engineer and extract private key from a public key. Okay. Now we'll come to the most important aspect about signatures. So essentially in technology, there is a, a breach which is known as man in the middle attack, that when I am performing, and this is what is, let's take the same Paytm example. So let's say Dinesh is transferring funds to Kritika. Now, when the transaction happens, accidentally on the server of Paytm, there is another entity who has gained access to it, and he is just manipulating the transaction. He changes that I have transferred 10 tokens to Kritika, but the entity there is in my favor, and instead of 10 tokens, he goes and just puts it as 1 token. Now, how does Paytm know that the data that it has received is actually come from Dinesh and not from any other entity in between me and the Paytm? So this is with the help of this digital identity, which is a binding mechanism to the data known as signature. And what it does is that whatever you type in this message, let's say I type here test message. Okay. To this message, I provide my private key. So there's a function to generate the signature, mathematical function, which takes the data, whatever is the data that you want to use to sign the transaction, and you provide your private key to it. And then the output of that function is the signature associated with that data. Okay. Now, to this, whenever you pass this signature to anyone, someone has to verify that has this data come from Dinesh. So you go ahead and give that signature to them. So if they use that signature and the same data, they extract the public key from it. And if that public key matches with the public key that was given into the body, then they say that the transaction has come from a trusted source. Okay. So I'll just repeat that statement again. So in sign, what we did is we took the data, whatever is data that is passed here, and using our private key, we went ahead and generated a signature. So now I have created a signature for my transaction. Now to Paytm, I give this signature and my public key, that this is the transaction that has come from me. So this message, the actual data, the signature, and my public key, these are the three components that I give to Paytm. Paytm takes the message, Paytm takes my public key, Paytm takes the signature, and he tries to go and compare. So in comparison, what happens is, by reverse engineering, taking the same message and signature, you can actually extract the public key that was used to generate this signature. And if the public key, the extracted public key from this process matches with the public key that was given as a part of the actual data, then you can safely say that this information has come from the original source and there has not been any tampering to it. Let's say someone just goes and changes that message. I just put this message here. My signature is generated from the previous, but here I've just tampered my message and I'm giving this. Now it fails. Sorry. Because the signature is the same, the data has changed. So from this data and this signature, it extracts a public key that is different from the public key that was used to perform this transaction, which is this key, which is this public key. So that is the reason it is able to go and say that this particular transaction has been tampered with, and that's where this transaction doesn't come into the database itself. Okay, so whenever I perform a transaction, along with the actual transaction data, I generate a signature, and in the body that I'm going to now issue to Paytm, I'm going to go ahead, give it the data, give it the signature, and give it the public key. The signature is generated on my infrastructure only. I haven't taken any external, any server where I have exposed my data. So within my own confines, I have generated the data, I have generated the signature, so there is no tampering to it. And then I just add the public key and give these three fields to Paytm. Paytm takes the message, it takes the signature, generates the public key from these two, matches with the public key that I have given. If they both match, it moves forward with the transaction, commits this transaction onto the network. If both the keys don't match, then it knows that this is a compromised transaction and this should not be accepted, and it rejects that data. Okay, so I hope this is clear. If not, please do visit this website, or you can go ahead and post your queries into the chat, and then subsequently we'll try to respond to your queries. So now coming into the actual transaction, the same thing happens, that now within the data parameter, it is that actual transaction that is performed. So like I said, that within the blockchain ecosystem, there is always the transaction that is shown between the public keys. So here is from is the public key of one account, 2 is the public key of another account, and we are transferring $20. So for this, the public key of this guy, because it is from the person who's going to initiate the transaction, his private key will be used, or any entity, like I talked to you guys about the initial aggregator entity, the entity that is going to commit this data onto the blockchain, that entity's private key has to be used. So in this case, the aggregator provides his private key. He takes all the transaction, groups it together, signs it, creates the signature, comes into the verify. Here again, the same transaction. If I do, it's simple verification. If I don't, I change it. I say that this is only $2 or this is $20.01. I go ahead and try to verify. The public key that is generated from this doesn't match with what was used to generate this signature. And that's where this record will not get committed onto the network. Okay. Same extrapolation within the blockchain, exact same, the previous examples that we saw. There are these A, B, and C. Someone comes, so this guy comes and he changes. Now, just for explanation, what Mr. Anders has done is, along with each transaction, he's created the signature also. Okay, so now theoretically, someone can just go ahead and make this change. So this means that this signature is invalidated, that the public key that is generated from this signature doesn't match with the original public key that was used to generate the signature. So even now also, if you go ahead and mine the block, although the aspect stays the same, that nonce will change, hash will change, there is one additional aspect that if you go and check, the signature still remains invalid because nobody has fixed that transaction. So that's where it is highlighted that this transaction is not valid. Other blocks, when they are also trying to accept this block, they will perform the same sequence, try to match that has the transaction come from original source. Because this doesn't match, this entire transaction data is rejected. So all the transactions are cancelled. The parties have to redo their transactions, and all these other valid transactions have to go in a different block. They will redo and they'll perform. They don't pay any transaction fees, except for this guy who pays the transaction fee for this particular operation that was performed. Okay, so this completes the foundational aspect. If you guys were with me till this point in time, fantastic. You guys have got a complete grasp about how blockchains work. And now with this foundation, you guys can go ahead and start practicing in any blockchain platform. These are the foundational concepts that are applicable to each and every blockchain. Some might have some other aspects along with it, but all in all, from a foundation perspective, these are the concepts. Okay. So let's just get back into the presentation. I'll just run through, and then I have two use cases. Hopefully those use cases should also give you what are the different problem statements that out there are being solved using blockchain technology. And once you get these slides, you will get an idea. I think these are pretty generic terms. Core concept here I've just explained. Distributed, we've already gone through the application. Decentralized also we've gone. What are the different consensus mechanism? Let's make sure, because you've understood now. So if anybody comes to you and says that consensus is proof of work or proof of stake, say yes, but not just that. There is the longest chain also that needs to be part of the consensus mechanism. So that way, please make sure that the others, whosoever communicates with you, their knowledge also gets enhanced with this. A quick intro into this. What are the different type of blockchains? So there are three basic type of blockchains. One is the public blockchains, which is what we have seen, which is accessible to everyone. And examples of those are Ethereum, Bitcoin, Cardano, and many others you would have seen as per your previous courses as well. It's the pro is that these are fully decentralized because it's accessible to everyone. Anybody can go build an entity and start performing the computation and put the records onto the chain. These are censor resistant because since it's everyone, there are a lot of participants out there. So to tamper a data becomes very difficult. Even to change the governance rules also is not easy. The problem with this is we already discussed that it's very energy inefficient because lots of computation cycles are happening, lots of energy is wasted, and more number of participants will lead to more proportionately increasing of the transaction time here. And one problem with this is see, not every use case warrants access to public. Okay, there are certain use cases. For example, within the enterprises itself, if one enterprise wants to go ahead and communicate with other enterprise, they need not do it open to the public. They can just go ahead and try to create something that is very isolated to only these two participants, and they can freely communicate with one another. So that is what transaction visibility means. So to solve these type of problems, which is mostly around the transaction visibility and controlled access, there are private blockchains. So just like public blockchains are open to everyone to participate, private blockchains are by invitation only. There is a network administrator who is responsible for onboarding participants and managing the network. A few examples are private Ethereum, Coda, Quorum, etc. These are mostly from an enterprise perspective. Typically, enterprises only look into the private blockchains. They don't come in the realm of public blockchains. With private blockchain, because everything is governed, you know the participants who are performing, you know their role into the transaction. So that way you can go ahead and keep the problem statements very simple. In private blockchains, you don't even need any gas, which is there as a part of public blockchain. The network operators goes and takes care of the gas responsibility. So every transaction is straight away committed onto the network. So it provides very high throughput. The security is also there because you know all the participants. The only problem in this case is that it's not truly decentralized. It decentralized only within the context that only the participants of that enterprise can access. So that way there is no true decentralization also. So imagine a scenario where there are three enterprises, two of the enterprise collude and go ahead and tamper the data. The third enterprise cannot do anything. It just has to go, leave the network, or just be part of the transaction there. Lastly, there is a permission blockchain. So permission blockchain essentially means is that you have to request permissions. You can be part of it, but you have to request permissions for certain operations onto the data. So let's say that me and Kriti are performing a transaction, and then along with me, I'm also having another conversation with another fellow named Gaurav here. Okay, now I'm performing transactions with Kriti and Gaurav, but I want to do so in a manner that the transaction between me and Kriti is completely secure, and transaction between me and Gaurav is also secure. Kriti should not know that I have also performed with Gaurav. and Gaurav also should not know that I have performed with Kriti. So this is where we go ahead and create private channels or private transactions between the participants who are relevant for it. So there will be a public channel where all three of us will be part of it, and then there will be some private channels where only me and Kriti and me and Gaurav will be part of those conversations and will perform our operations. So this is known as permissioned. Almost in lines with private, it has a better throughput, better performance. You can go ahead and customize the governance also within this. The problem here is like visibility. It becomes very difficult to know which transaction, which who's there, how many total transactions have happened, because my I have done two transactions, but when Kriti sees, she only sees one transaction. When Gaurav sees, he's only aware of one transaction. So that way it becomes difficult to have a proper across the board security mechanism. So just some examples here. Okay. The trilemma, we briefly touched upon this, that the blockchain is formed on the core concepts of security, which is more number of participants, but at the same time more number of participants will yield to scalability challenges. And then how do you balance a decentralization aspect with security, with scalability? Many of the platforms just focus on they make sure that security is there, because if security is not there, if anybody is going to go ahead and tamper your data or manipulate your data, then that platform will not scale. So most of the guys compromise on the scalability aspect or on the decentralization aspect, but they ensure that security is always covered. But again, it should be case to case dependent. For example, if you're just doing on a very basic piece of data, very basic piece of transaction, where data security is not important but the scalability is very important, that way you can go ahead and compromise on that aspect. So it's always on case to case basis. This is not a de facto principle. Whatever use case you are trying to solve the problem for, align with that, you can go ahead and so focus on the corresponding aspect for it. Current state, just a quick introduction to this, is that like today's platforms are all known as layer 1 platforms, where these are the foundational networks. But then the foundational networks have grown so big that there are a lot of challenges that to perform every transaction there is a high cost of transaction. The time for transaction is also low. So then there are these layer 2 solutions, which are forks or pivots on top of layer 1, that allow you to do the transaction only on layer 2. So you are no longer worried for layer 1. The layer 2 protocol in itself goes and manages layer 1. Again, just a brief introduction. You guys can go ahead, at least this gives you the overview, but probably you guys can go ahead and do some reading on your own. But my this thing is focus on layer 1 first. Once you have a complete understanding of the layer 1 foundations and concepts, then layer 2 is just a wrapper on top of layer 1. You are still dependent on layer 1 for your transaction to be committed onto the network. Okay. I quick this thing, I wanted to show you some of the use cases that couple of my colleagues have built. So this one is where we have, again, it's a prototype. This was done almost 3 years back, where using voice based chat operations, we are able to perform the transaction from one to another. The use case here was that especially India is a very low penetration smartphone economy, and almost 65% of our economy uses feature phones. How can we enable the unbanked to go ahead and come onto these digital platforms? So this is one use case. I'll just go ahead and play it. Hope the voice is also there. If not, please let me know. And subsequently, I'll go ahead and post the links onto the chat.
Please tell me your passcode for authentication.
Concert icon process copper.
Hi, Srikant. Please choose your option. Balance inquiry, balance transfer.
Balance inquiry.
Your total account balance is 10,000 United States dollars.
Balance transfer.
Awesome. Srikant, please select your target account for transfer. Dinesh Gaurav Manoj.
Dinesh.
How much amount do you want to transfer to Dinesh?
1000 USD.
Please confirm.
All right.
Transaction success. Would you like to continue? Quit.
I will continue.
Sure, Srikanth. Please choose your option. Balance inquiry, balance transfer.
Balance inquiry.
Your total account balance is 9,000 United States dollars.
So this was one use case. Again, it was just a demo. It was more as a proof of concept. So all the numbers there were mocked up numbers. I wasn't lucky enough to get 1000 USD there. So this is another example wherein the first one you saw was in the space of finance domain, where we were actually transferring funds. This is in the space of supply chain, where it is used to track the asset, as well as it is used to track the funds that are used to create the asset. So this is on the lines of collaborative lending, where not whenever you go and would want to go ahead and take a loan, the lending party need not be one. Many lending parties can come together and fractionalize the amount that they want to go ahead and lend towards it. So this is known as mostly the public lending or the collaborative consumption model. So again, very use case, simplistic use case, but the idea is that the technology is also applicable to other domains. So it goes a bit fast, so I'll just go ahead and just brief it. So step one was where we onboarded an entity, Reliance Digital. So whenever you onboard, one of the things that has to be done is your identity, which is the public key, private key, has to be communicated and said that this is my public key. Going forward, I'm going to use this public key. So now everybody knows that, okay, if public key with that XXX comes, that is associated with Reliance Digital. And whatever transactions are happening with Reliance Digital, everything will be tracked with that public key from that perspective. So now this is where the use case is that Reliance has got an order. Reliance wants to go ahead and take 1,000 or X number. I don't know how much number has been kept, but imagine that Reliance has to go ahead and take 1,000 iPhones from Apple. So Apple is the seller, Reliance is the buyer in this case. So now for Apple to complete this order, it needs to go and take the loan from the banks or from these lending institutions. So what it does is it takes this order from Reliance Digital and goes towards the lenders and says, see, I already have received an order. I want money to fulfill this order. Once the order is fulfilled, I'll go ahead and make the payments to you. The lenders see this order and they go ahead and provide the loan request. The challenge with existing systems today, this is known as bill discounting or letter of credit. The challenge that happens today is that once you get the letter of credit, you can use the funds towards any other purpose. It need not be necessary for the same purpose for which you had taken the money. And for this, there were several scams, very famous scams that had happened, that had rocked the entire Indian economy also. And that's where the government had come back and said that we want to go ahead and build trust into these use cases. So they had asked us to go ahead and figure out what are the ways, what are this thing, us as in the digital, not us as in per se us, but us as in they had created a hackathon. And then we had provided this recommendation of using blockchain to finance, to support the entire ecosystem of issuing the loan and then tracking the loan and making sure that the payments also happen via tokens itself and not anything in fiat. So everything is automated within smart contracts. This solution received the first prize at the hackathon, and then we had done a pilot. Unfortunately, the solution didn't go beyond pilot, but at least 3 years back, there was a lot of thrust on these type of use cases. Okay, so that's the background. Just see if you are able to follow along with it. So here he is giving the order purchase of iPhone. The contract is valid from what date to what date, provides the details of iPhone, provides the quantity and the price. So now a contract gets created for this order onto the digital blockchain, where Reliance has created the contract. Now Apple has to go and accept the contract that yes, I do have this order and I have to fulfill this order. So in a contractual agreement, typically there are two parties, from and to. All these agreements have to be acknowledged by both the parties, and only when it is acknowledged by both the parties, that agreement becomes the de facto agreement. Until then, it's just a copy that you are having with you. So now it goes into the buyer marketplace, puts up this order, and tries to get marketplace quotations to see that for this order, who can provide it the best possible loan terms with higher value and lower interest. So this was a marketplace platform that was conceptualized. So it goes into the amount, and again, all of these transactions are traceable. How many, this thing, everything was the aspect on blockchain itself. So now this guy goes and says that, okay, ICICI has given me an order. They go ahead and acknowledge the amount from ICICI, and both ICICI creates the contract and Apple accepts that contract. So now there are two contracts essentially. One between Reliance to Apple, other between Apple to ICICI. So now after this, Apple goes and makes, and even for raw material procurement also, it needs to go ahead and get into an agreement with its vendors. So even these transactions are recorded on blockchain, and as and when, let's say that Apple is shipping for processors from Qualcomm. So the moment even this, in this case, the contract happens between Apple and Qualcomm, and it gets linked to this order, to this contract from ICICI. That way, whenever the order is fulfilled, automatically the funds will be dispersed to Qualcomm, and ICICI will get a notification that yes, there was a usage of funds towards the same order, and the payment has been made to Qualcomm for what purpose also. So that way there is a complete traceability into each and every line item and transaction that is happening onto the platform. Now once they acknowledge Reliance has got this thing, so funds automatically gets transferred, and then essentially everything gets credited here. So it was a complete end-to-end automated solution. But the general gist in this case is that look at the use case that was there. So the use case was basically an actual process that was running within today's context, which had a lot of loopholes. And then the same use case was translated into the platform-driven use case, and how those inefficiencies were getting addressed with through the platform. Now, because it was done as a hackathon, the UI and everything was very, very primitive. The idea was that within 6 to 8 hours, this entire use case was built and demonstrated. On top of this, we can have some fancy UIs, nice intuitive experience platforms that can go ahead and mask the complete complexity and make it very user friendly and intuitive to go ahead and use the platform. Okay, so hope you guys got a good understanding from here about the use cases, the potential that the platform has, the technology has to offer. And in coming days, you guys are able to build strong foundational use cases, take the technology to the next level. That will not only help the overall economy to prosper, but even from a global perspective, the visibility about our efficiencies and processes will also be taken to the next level. Okay, so with this, I take a pause here. The entire whatever aspects I had to cover, I've gone ahead and covered. We'll go ahead and share the material with you guys, and subsequently, if you have any queries, any clarification, please go ahead and post it onto the Discord, and we can take the conversation there. Okay, hope the session was informative and you guys were able to have some key takeaways from this session. Thank you for your time.
Thanks a lot, Dinesh. There are one or two questions. Do you have some time to tackle it?
Sure, we'll go ahead.
So this was posted a while ago, but Kiran asks, what factor decides how many transactions a block can hold? Is there a transaction limit to which upon crossing a new block is added?
So it's a time boxed window So essentially, it's not based on the number of transactions. So theoretically, within that 5 minute gap, let's say that we have created a time box window which is in the 5 minute. Now, from a transaction problem perspective, let's assume the current proof of work only. We've kept a very simple problem where the transaction is just to get zero. So now whenever anybody is giving the transactions within the block, they have to give along with the signature also. So if we keep everything as simple, the number of transactions coming into the block will be very high. But at the end of the day, when the cutoff happens, we just take all the transactions within the cutoff. Just like in a big data ecosystem, there is a 16 MB and 32 MB size limit. With a blockchain block, there is no such size limit to it. It is only driven how many transactions are captured, but that also takes into another factor, the cost of transaction. So although there is no limit, if higher blocks with more space, which has more number of transactions are captured in it, essentially the cost of transaction, because your cost of transaction is just taking that block and committing onto the network, performing the computation. So computation is just being performed once to generate that nonce. That gives you the 40. So the cost of transaction can be split between all these individual transactions. So theoretically, you expect that I'm going to pay a low transaction fees if I'm getting grouped into a high volume block. But at the same time, to commit a high volume block takes more time because the other nodes might not follow the same path and they might be looking at a slightly lower volume, lower window. So that way it contradicts its own principle that a high volume should lower the cost of transaction. It just bumps up the cost of transaction because of time. So from that perspective, the aggregators, the ones who are going to take the transactions, put limit and try to make sure that they do it at an optimum size. And this optimum size is decided by them only. There is no hard and set formula for it. They decide which can be anywhere from 10 transactions all the way up to 100 transactions also. And these transactions in a blockchain, the transactions typically are very simple. It is just from and to, and you don't try to keep any other data. The actual data of the transaction is kept elsewhere. Otherwise, you will start incurring heavy cost and this thing. So the actual data of the transaction is kept in IPFS or some other reference. Only the reference to the transaction is what gets tracked. So just coming back to the response that no, there is no such defined limit. It is only driven by the time boxing window. But aggregators who are committing on behalf of the individual participants to optimize their infrastructure so that they don't go ahead and overshoot their infrastructure, they put some limits which can be anywhere to a block, the block that can hold up from 10 transactions to 100 transactions. So hope that answers the question.
Yeah, I think it was a very good answer and elaborately, like you described why as well. And Nikhil has asked a very related question. How does the previous blockchain hash affect the next block, as the hash for a block depends upon block number, nonce, and data only? I think it's more just like similar to your linked list concepts, where it's just directing to the next block per se, but doesn't have to do with the data in the previous block. But I'd let Dinesh answer it in detail.
Sure. So Nikhil, it is not just block, nonce, and data, it is also the previous hash. So that links to the current this thing. So it's these four: block, nonce, data, and previous hash. So previous hash always gets carried over. So like for example, in this example, the hash 4015 is the same one that gets carried over 4015. So the moment you change anything, this hash value is what is getting captured here. So when you mine this gets reflected here, but then you have to mine the same also to make sure nothing else has changed in this. So if you see in this, the block has stayed the same, the nonce has stayed the same, the data also has stayed the same. What has changed is only this previous hash, because of which the current hash also changes. So now you need to go back and mine this to make sure that this also aligns with the effect. But this is how the linking happens, that you take the hash of the current block and pass it into the previous value as the previous hash of the block.
Got it. Thanks, Dinesh. And just one last question. Does the miner get penalized if block signatures do not verify? And if yes, how, what is the penalty? Like in PO, in proof of work, what's the penalty? In proof of stake, what's the penalty?
Sure. So there are two different aspects. One is the signature validation, so which is what we were talking about this. So these are signature of the transactions that are coming from individual participants. So this is one transaction, this is one transaction. So in this, now let's say that I am hosting an infrastructure where all these transactions are come to the network. So I group all these transactions, and now I'm taking and committing these transactions to the network. So in this case, I'm not the generator of the transaction. I'm the gatekeeper to make sure that any invalid transaction doesn't go through. So that way I'm a gatekeeper. I will not be penalized if these transactions don't align the signature. But if I'm putting an invalid block, let's say the hash, which is the signature also in a way, that the block hash is invalid and I'm continuously putting up invalid blocks onto the network, I'm chewing up the network capacity and I'm delaying the commit process. So in a proof of work, if for 3 times I'm continuously providing wrong blocks, my node gets kicked out. I will not be able to sync with the network. So then my infrastructure is decommissioned. I have to bring up a new infrastructure, new identity. Essentially, that public private key pair that I was using to put the data onto the network is no longer valid. I have to go back, create a new public private key pair, and then come back and start acting as a miner here. So in a proof of work, essentially you cannot mine any further. You can be there, you can just read the chain and you can replicate the chain, but you cannot mine any further onto the network. That's the penalization. And in case of proof of stake, your stake is lost. So it is whatever, to even participate, you have to put up a stake. So one is your stake is lost. And there is this aspect also, again, it's not yet implemented. Once beacon comes, then only we'll know whether that aspect also been implemented or it's in future release, is that up to a certain number of invalid attempts is allowed. But after that, for example, first time you do an invalid stake, I mean, you are putting an invalid block onto the network, your stake is lost. For you to participate into the next reward cycle, the probability starts diminishing. So let's say that there are 10 participants into the network. So now the network has defined a rule where randomly it is going to choose 5 nodes who are going to participate into the transaction. From these, each of these 5 nodes go ahead and put their data, and then they start validating the records and go ahead and put it. In the next round for commit, some other 5 nodes will be chosen. So if one of the node acts in a malicious manner and provides invalid blocks, the probability of this node getting selected starts diminishing. And then after a certain number of invalid attempts, this certain is subjective. This becomes that this participant can no longer be part of the reward cycle. He can only be there just to read the transaction and sync with the chain, but he will never be chosen to commit the records onto the network.
Got it. Thanks a lot, Dinesh, for explaining in detail.
Sure.
And thanks for jumping in on a Sunday evening and attending the session. If you have any more questions, you can post it on the Discord server, and we'll get back to you. And Dinesh, the participants have also been asked to come up with their own problem statements, and we'll also be presenting some more tomorrow and day after for them to come up with case studies on. So looking forward to that bit as well. And if you have some problem statements to share, you can share it on Discord, and we can help them understand those during the sessions and work on some problem statements like the applications that you did showcase towards the end.
Sure, absolutely. I think one key aspect, guys, I'll like to leave you with the thought that technology is just there to support the use case. The reason blockchain is taking time to find its foot into the actual ecosystem is that there was a hype cycle that everybody wanted to take blockchain for anything and everything, which in the ground reality, it doesn't work. There is a cost to maintain blockchain infra, and enterprises or even the public ecosystems, the public services, the governments, and any entity who's going to host the infrastructure, they have to bear the cost. So not every use case warrants the blockchain, but think of blockchain as complementing to the existing processes, not supplementing. Blockchain is not here to replace existing systems. It is here to put trust into the existing systems, enhance the existing systems by making them more efficient and process driven. So whenever you are thinking about any problem statement, make sure you look for two key aspects. Are there any external participants with whom there is a need to share the data? Only if there are external participants. See, you trust internal participants. You don't discredit your internal participants. They are part of your ecosystem. But whenever you are sharing the data with any external party, that is where you need to have a trust with the external party to make sure that the data goes into the right hands and is not used in a not so approved manner. The second is that the data that is being exchanged, is it critical enough to warrant the trust in the system? For example, if all I'm doing is just, if someone has sent me an invoice over email and I just have to acknowledge, I don't have to put the acknowledgement onto the blockchain, because it's okay. Even if I don't acknowledge, nobody will have, again, it's within the context, but nobody will have any problem with that why did I not acknowledge, or why did I not put. Again, it's use case. Certain use cases do warrant an acknowledgement. Even an invoice also does warrant an acknowledgement, because the credit cycle starts from there. But the gist here is that please make sure that you look at the use case from a critical lens of external participants and data sharing, and only if it meets these two, then start placing it back that what are the processes that can be taken on blockchain, what are the processes that can be taken within the existing system only. And that way, will a pure play blockchain solution be good, or a hybrid solution where the not so critical processes are continuing onto the existing application, and only the critical processes which require exchange of data with participants get replicated onto blockchain. So whatever use cases you are coming up from your project, please have this critical lens. What we will be looking at these use cases is only understanding how much foundationally you have understood about the use case, and what are the problem statements that you are trying to solve from the use case. Okay. And any use cases, please make sure you go ahead and put up onto the Discord. We'll review it, and whatever are those top couple of use cases, and Kritika will certainly share those details further. But those top use cases, we'll go ahead and subsequently have detailed discussion with you guys to make sure we refine your use case, and it's in a position where you yourself can go ahead and start building the use case on your own and take it forward to a future DAO also, if it pans out. Okay, sure. I think that's it from my side, Kritika. Thank you very much for having me here. Thank you everyone for attending this session. I apologize for spoiling your Sunday, but I think this was the only time where we could have had this session without any interruption. So hope you guys were able to take some key takeaways from it. And if any queries, just please feel free to reach out on Discord. We'll try to address your queries. And in general, just have a good Sunday, good evening, stay safe, take well, and have a good day ahead.
Thanks a lot, Dinesh, for taking time off of your busy schedule. I know you've been jumping around traveling, but thanks for making time and doing this.
Thank
Means
you.
a lot to all of us.
Thank
All
you.
right, then have a good evening, people. We'll see you guys tomorrow in the session, as well as next week for the next masterclass. Bye.
Thank you. Bye-bye.